Many of the most successful theories in physics are built around boundaries. Equations work up to a point, like wave function collapse or the center of a black hole, and then they stop. In these models, the concept of zero is essentially a mathematical wall. This boundary was challenged by a researcher who encountered a recursive vision of emergence. It suggested that the dead end of zero might actually be a dense field of data. The vision described three specific geometric transformations. A single line in motion curves into a loop, returning to its point of origin. Then that circle undergoes a spatial twist, becoming a figure 8, the topology of infinity. Each step represents a physical transition. The return to self loop creates the first stable vibration. The figure 8 twist allows those vibrations to lock into a phase-coherent state. This defines zero as a structure of specific measurable resonance. Viewing zero as a structured field rather than a void changes the aim of physics. Instead of stopping at the boundary, we can finally begin to investigate the mechanics that occur inside the wall. To test if this geometry held any real physical weight, the researcher translated the vision into a rigorous mathematical framework. The math produced a result difficult to ignore. Interlocking three geometric constants, phi, pi, and alpha, the model calculated the mass ratio of a proton to an electron to 0.000075% precision. This was achieved without adjusting free parameters to make the numbers fit. Precision on its own isn't a discovery, it's a pointer. It forces a difficult conversation about what parts of the math are being derived from geometry and what parts are just being supplied by existing physics. To find the answer, the program began dismantling the black boxes of physics to see if this geometric structure could be found inside the variables we take for granted. When the researchers looked closer at the components of their model, the labels used to describe the universe began to split into more complex parts. Momentum is usually treated as one thing, but high-resolution analysis reveals it fractures into 15 distinct objects. Noether momentum, kinetic momentum, and canonical momentum all have different mathematical structures and different physical roles. The term backaction undergoes a similar fracture, splitting into 4 distinct categories. By grouping them under one name, we hide the specific ways matter interacts with its environment. These concepts are coarse labels. They are simplified shorthand for a much larger, deeper territory of relational physics that standard models don't currently map. The boundaries we thought were the end of the line are actually complex systems masquerading as single variables. This research points to a 3-layer architecture of reality, where the physics we observe is just the visible surface. The foundational layer is relational mechanics, a dense network of every possible physical relation. Above is resolution mechanics, an aperture selectively filtering data from below. The top layer, oscillatory dynamics, is all we measure, patterns stable enough to survive the filter with phase structure intact. What we call reality is the survivor of a specific observational aperture. We experience this architecture every time we drive a car. A driver doesn't perceive the total relational state of the highway. They perceive an estimate built from specific apertures, the windshield, the mirrors, and the dashboard. A physics observer works the same way. It is a bounded system that constructs a version of reality through a limited, weighted set of apertures. This reveals that smear is quotient. The macroscopic world we see is a product of equivalence. Spacetime looks smooth because our specific aperture takes millions of distinct microscopic states and declares them all equivalent. We mathematically group them into a single macro block because we can't resolve the differences between them. The macroscopic reality we inhabit is a stable, objectively real byproduct of our own lack of resolution. If our reality is a filtered projection, what happens to all the physical structure that doesn't make it through the aperture? Suppressed structure doesn't just disappear, it bleeds back into our observable world. This suppressed data re-enters our description in 2 ways. We see it as memory, the way past interactions influence the present, and as backaction, the physical disturbance that occurs when we attempt to measure a system. Memory and backaction are 2 views of the same physical return. They are the signatures of the data that the aperture tried to discard. The noise and friction in our equations are the traces of a hidden structure we haven't accounted for. This leads us back to the original question: what is actually inside zero? 0 is a full zero. It is a deeper substrate, saturated with connections, vibrations, and physical relations. This approach treats boundaries like wave function collapse as structured projection mechanisms. These aren't points where physics fails. They are the gears of how reality is constructed. The universe isn't hiding behind an uncrossable boundary. It is projecting its deep nature to us through a resolution we are finally learning how to reverse engineer.